Now we're going to go into stratified random samples. You divide your population into similar groups of individuals. We'll call those strata. Then, from each of the strata, you're going to separate a simple random sample in each of the strata. Then you combine these simple random samples from each of the strata to form the full sample. So let's look at an example of how this is done. Suppose the university has the following student demographics. 55% come from undergraduate, 20% from graduate, 5% from first professionals, and 20% from a special category. So these are our strata. Let's see how we could make a stratified random sample of 100 students. Let's see how this could be done. What you would do is you'd say 55% of our 100 sample should come from the undergraduates. So you'd say 0.55 times 100 to get 55 in your sample. So you'll take a simple random sample of 55 undergraduates. Then you would find 20% of our stratified random sample from graduates. So 20 of our random sample should come from graduates. So we'll do a simple random sample of our graduates till we get 20 of them. Then we're going to get 5% of our sample. So we'd say 5 times 100. And so that would be 5 would come from first professional students. So we'd take a simple random sample of 5 from the professional students. Then we want 20% to come from our special category. So we'd say 0.20 times 100. That would mean 20 will come from the special students. So I'll take a simple random sample of 20 students. When I combine all these strata, I will have 100 students altogether. Now let's take another example. What if I wanted 150 in my sample? How would I do this? Well, let's say, to make numbers nice, let's say we want a sample of 200. How would I go about finding my stratified random sample? Well, I want 55% of my sample to come from undergraduates. So if I want a sample size of 200, I'd say 0.55 times 200, which gives me 110. So I'm going to have to take a simple random sample of undergraduates, and I want my simple random sample to have 110. I want 110 in my simple random sample from undergraduates. I do the same thing for my graduates, 0.20 times 200 to get my how many I want in my simple random sample. So when I do that multiplication, I get 40. So I want to take a simple random sample of 40 graduates. I would do the same for first professionals, where I'd want 5% of my sample to come from first professionals, so I'd say 0.05 times 200. So I'm going to take a simple random sample to get 10 first professionals. And the same thing I'd do for the special category. So I'd say 0.20 times 200. So I'd want to take a simple random sample of 40 from my special category. So I'd add my 110, 40, 10, and my 40 from my simple random samples from each of the strata to get my complete sample of 200. And that's how you do a stratified random sample. Now in multi-stage sample, you have several stages of sampling that are carried out. Now these are used for large-scale sample surveys. Now samples at each stage may be simple random samples, but a lot of times they're stratified. And the stages may involve other types of random sampling techniques, like systematic or cluster sampling, which we didn't go into in this chapter. Now if you have to take a sample survey, there are some cautions with doing that. You can have undercoverage. That means that some of the population isn't represented in your survey, in your sample. Non-response are individuals chosen for the sample cannot be contacted or refuse to cooperate or respond. Sometimes these non-responses are extremely important, and you need to have their input in the particular question that you're asking. You have response bias, that's behaviors of the respondent or interviewer that can lead to inaccurate answers or measurements, and wording of questions, confusing or leading questions, words with different meanings, any kind of biased question. Now, an example of the non-response was the Height book. 4.5 responded to her book. They were probably the angry women were more likely to respond. So we didn't hear from women that didn't have a particular beef about their relationships. So those that were not represented weren't put into her statistics in her book. A door-to-door survey is being conducted to determine drug use, past or present, of members of the community. Respondents may give socially acceptable answers, which can sometimes not be the truth. And let's think, if a policeman came to the door, what do you think about that, conducting that particular interview? So there the interviewer might have a very big part in how the interviewee answers. And these are quite interesting. Now, the Washington Post National Weekly Edition, they asked a question. A 1978 poll done in Cincinnati asked people whether they favored or opposed repealing the 1975 Public Affairs Act. Now, there wasn't a 1975 Public Affairs Act, but 1/3 of those asked expressed an opinion about it. So sometimes people, like I said, they kind of want to, they respond to the interviewer, don't want to look dumb. You have to be careful about the wording of the question. Sometimes if it's too complicated, it's hard for people to answer. Sometimes we pose a question of where we put a bias in the answer. Look at these two. Now, if someone asked you if you found a wallet with $20 in it, would you return the money? Now, if someone had asked that in another way, if you found a wallet with $20 in it, would you do the right thing and return the money? That puts a bias on that question. We have unintentional bias, where certain words have certain meaning or connotations, and we don't really wish to do that, but sometimes we can do that also. And sometimes the ordering of our questions can lead the person taking the survey into an answer that we want. So we have to be careful of the order of how we ask. Now, why is it so important to get a good sample? Well, we take the values calculated from these samples to make conclusions or inferences about the population. So if we don't have a good sample and we're making these generalizations to the population, not a good thing. So we really want to make sure we have a very good representative sample. Now, different samples from the same population may actually give us different results. That causes the variability. As our sample gets large, our estimates from those random samples will get closer and closer to the true values of the population. Now, how close our estimates will likely be to the true values? Well, that can be calculated, and that's called the margin of error. We're going to learn all about these very soon. Well, that concludes Chapter 8. Producing data, sampling.